Hi, everybody. I'm Eileen. I think most of you already know me on this side, at least. And I'm here to present on the CWU commuter analysis project that I did for the sustainability department here on campus. So first, I'm going to talk about what exactly is sustainable transportation, why it's important, what is CWU doing to kind of move towards that, what was my research question that I investigated to answer, some things that we had to look at, and the methods I used to do that, and then what I found. So first of all, sustainable transportation is this move towards a more sustainable development, and we want to combine sort of like social, economic, and environmental aspects when we're looking at it. So thinking of how we can bring the greatest good to all of these things. And what does that look like at CWU? We want to cut down on greenhouse gas emissions, but we have to kind of look at where the people are, what are their commuting patterns, how to visualize that, and that's where GIS software comes in. So geographical information systems, if you're not familiar, it's just a way of mapping and adding data to visualize. And what that can help us do is, again, understand patterns and then identify potential areas that we can improve and provide people access to those. So the research question was, where are Central Washington University commuters located and how many miles are they commuting each day? Step one to this was identifying what was a reasonable study area for this, that we decided it was 60-mile driving distance. And that's not to say there aren't people outside of this distance, but this is what we thought was most reasonable. So you can see it kind of continues up to Snoqualmie Pass and then all the way to Wenatchee, east of the Columbia, and then all the way down to Yakima. The next step was to break this down into 6 zones, and that just kind of came naturally based on what Kathleen had to say. And you can see the biggest zone is the purple on the edge, and that was 30 to 60 miles. The next one in is 10 to 30, and that's the blue zone. The green zone, which is 5 to 10 miles, 2 to 5 in the yellow, and 1 to 2 in the orange, and red was the closest, which was 0 to 1 miles. The next step was to find out, add this tabular data, which had all the addresses of all the employees at Central Washington University. And what we did was put those on the map, and we use this process called geocoding, which is a way we take the table and then we put it into GIS, and it generates a bunch of points based on the addresses and then adds that to the map. And because that's sensitive data and you can't really share it, I went ahead and joined those to each of those 6 zones. So you can kind of see in the right corner in the map key, the percentages of people within those zones. And we have the lowest amount of people in that blue zone. It was only 4%. And then the highest amount of people were in zones 0 to 1 and 1 to 2, making up over half of the employees. And then what I went ahead and did was use this thing called routing, where you actually can find out the driving distance from their point on the map to CWU. And then that was also added to the table to find out how many miles they were driving each day. And then it's a lot of data, so you had to kind of represent it cartographically. And that was the biggest challenge, I thought. I worked with Dr. Quinn on that. And what we did was kind of a little zoom in on each of those zones, 0 to 1, 1 to 2, all of those, and then added the percentage of people within those zones, and then an arrow towards the zones with how many miles they were commuting on average per day, if they were driving or walking. And what did I find from this? Over 50%, like I said, of employees are in those really close zones, 0 to 1 and 1 to 2 miles. And they commuted about 3,000 miles per day in combination. But the real kicker was you can see that this little slice of the pie on the bottom, purple, 10.1% of commuters in the 30 to 60 mile zone actually contributed more than half of the miles commuted per day. And you can see that's 19,000 miles combined. So that was really interesting. So a small piece of the people are commuting a lot of miles. What we found was that a lot of the addresses from employees were PO boxes, and we figure people don't live in their PO boxes, so we couldn't really use that data. So that a lot was eliminated. So I think moving forward, finding more accurate data, actually surveying where all the employees are physically, their telework info, are they actually coming in to the university? And then what are their modes of transportation? So you can find better ways to help and move towards a more sustainable transportation. And then same with the students. We had intended to use student data, but a lot of it was on the west side, and we imagine students aren't commuting every day from Seattle. So we think potentially it was their parents' addresses, but yeah, so getting more accurate. And I think the sustainability department actually put out a survey recently for students, which I took, and everybody should, but yeah, so I think they're trying to investigate this. And then once that's done, all the data is a little bit more accurate. They can go ahead and do some more analysis on like, where are the bulk of people and how can you make more sustainable transportation options, give them those, and create better access. And yeah. So thank you to the sustainability department for letting me dive into this with GIS. It was really fun and interesting. And also to Dr. Quinn for really guiding this project and showing me where things were and how to do the cartographic exercise. Yeah, any questions?
I'm curious where existing public transit exists within those zones, like which zones have public transit on a daily basis. CWU.
Yeah, that was kind of the next step. For the sake of this project, it was just answering that question, but definitely that was something that was brought up. And there is something that goes from Yakima to here and then also Jellum to here. And the times are limited when it goes, but there is that. And then there's central transit. But yeah, it would be awesome to visualize it among this data.
Do you have a sense that faculty and staff use those as well? Is that
We're not exactly sure, and that was kind of in my like further research section where like we don't know what people are doing. We don't have enough data, so it would be good to find out. Yeah.
With the routing algorithm,
Yeah, so it's a new feature on ArcGIS Online, and you can actually plug all your data in, and it finds the quickest path on a road. Distance, I think. Yeah. Or time, probably. Yeah.
Thank you.
Okay.
Oh.
Oh. Oops. Sorry. Oh, yeah, okay. Yeah, it took me a quarter long to answer this question or this project. Yeah. All right, any more questions? Cool. Okay, I'm back again. I'm still Eileen, but I'm presenting on something different. Okay, so some other research I did this past quarter was inspired by Mara Gans, who's in the audience right here. So you should watch her presentation next. But what I did was look at lexical data in the Alpine Lakes Wilderness, and I will tell you a lot more about that in the next 2 minutes. So first of all, we have to look at where is Alpine Lakes Wilderness, if you're not already familiar. What is lexical data analysis? Okay. Well, I'm sorry to the people who are watching online. We're having technical difficulties. Okay, so yeah, I was talking about basically where is the Alpine Lakes Wilderness? What is lexical data analysis? Why is it important, especially in land management? And how did I do that in the Alpine Lakes Wilderness? So first of all, the study area. This map is from our Gans thesis, and you can see the big red blob in the middle. That is the Alpine Lakes Wilderness. You might be familiar driving over Snoqualmie Pass or near Leavenworth, Highway 2. That's all areas you can access the Alpine Lakes Wilderness. So what is lexical data analysis? It's this process of gathering like raw text data. Sometimes that's voice, sometimes that's reviews online, and then you can code, structure, and prep this data in order to analyze and process it, visualize it, and then gain insights from that. So here's an example. Up there on the top left is a text review online of actually the hike I'm going to be looking at. And then down below, I kind of split it apart in tabular format so you can analyze it. And then down on the right, those are just examples of how you can analyze and visualize this data. So why would you use lexical data? Number one, there's a huge pool of it online. 80% of the world's data is actually raw and unstructured. We just haven't tapped into all of it quite yet, and it's going to keep growing. There's been a huge growth in people recreating in the outdoors, especially since COVID-19. And land managers are struggling to keep up with all of this. And they're overwhelmed, and their current recreation model is outdated. And we have like fat squirrels and dog poop bags everywhere, and we're not sure why. And I think a piece of that missing puzzle is studying what people are saying and the social ecological perspective of that, which is connecting kind of people to their environment. So why did I do this? What did I do? Well, Mara was looking at geotags in the Alpine Lakes Wilderness, which is just a location that's attached to, usually on social media like Instagram. It's a location attached to somebody's post. She looked at this and found the most dense areas you can see here in her map. And then she went to these locations and surveyed. And I saw a lot of text data, and I was like, this is really cool. And what she found was that a lot of people referenced using hiking and outdoor recreation specific websites. Those are apps people use to find out about the hike they're going to do, and they leave reviews, raw text reviews. And so what I did was I chose a specific area right here in the Core Enchantments called Kulchuk Lake. And I looked at the reviews from September of 2021 on All Trails, which is one of those websites. And what did I do? I coded, structured, and prepped this, which took a lot longer than I thought. It's a long process. And I did it both manually and in Python. So I ran it through a script, and then I kind of checked it by hand. And then I also did some on my own just to see how that would kind of differ. And then I processed and visualized it using manually. So me, Illustrator, Python, which is free and open source. And I did a few things in there, and then Tableau, which is proprietary, so it's private and it costs money. So this is an example of manual coding. I chose what the main subjects of the reviews were, and you can see some of the main topics are trail, parking, hike, lake, view, even UFO and Instagrammers, which I thought was interesting. And then I kind of connected what people said about these places. Why were they saying so much about these specific things? So one of them was last mile. And people thought that it was really tough. A lot of people referenced the last few miles. They said there were a lot of rocks. It was like a Stairmaster. It was really challenging, but worth it. It was tough. And then they also referenced the parking a lot. It was packed and full. You can even see somebody said by 6:25 a.m. on a Saturday, the parking was full. So this is really interesting that you can gather this much from reviews and then just visualizing it really quickly. So this was a bit of Python processing, and then Tableau, I visualized it in there. And these are some of the top 3 sentences or phrases people used. So again, that last mile of the hike, the road up, people said it was really potholy. The lake was a huge topic, obviously, because it's beautiful and you should go there if you haven't. And then here's just the same thing, but with all of the 3-word phrases that people used. So this was another one. Python kind of categorized people into positive and negative reviews. And here's an example of that. I put the most polarizing, so this doesn't include all of them. This is the most negative here on the left, and then the most positive there on the right. And you can see when people weren't having a good time, they were saying the rocks were brutal, as coming down was harder than going up. any harder and it would not have ended well. It was incredibly difficult. At times, it was absolute hell. And then on the other hand, people said the road and trail were rough, but the destination was beautiful. Pretty good workout with an amazing view of the lake and mountains. So what did I find? So the processing of language is really complex. You can't just run it through Python like I thought. It categorizes it for you. There's semantics, there's colloquialisms. It's very site specific. So it takes somebody who knows what's going on at this place. And Python doesn't really understand sentence structure, and especially if it's informal. And here's some examples of that. If I had a bad knee, I'd still be sitting up there frozen to a rock. A computer might think this is literal and maybe not what you think it is, and then strenuous, but worth all the pain. So yeah, and that might be seen as negative by the computer because it has more negative words, but it's not necessarily negative. And I think this kind of data can really help land managers. Number one, like I said, have that social ecological perspective. So identifying how people are connecting with their environment and why it's of value. And then also identify problems like you saw with the parking and the road, and see like things like crowding and trail maintenance and litter without having to go out to all these sites all the time. So further research, I think it would be awesome if they kind of connected these sources to sort of a data processing site like Survey 123 for the Forest Service, so that it can be incorporated more in land management and help provide those insights quickly and efficiently and shareable. Yeah, so huge thank you to the Office of Undergraduate Research for letting me help Mara. I learned so much from her and Dr. Quinn and Dr. Lipton and the CWU library and Tableau. So yeah, I'm really appreciative of all that. And that is all. Thank you. Do you have any questions? Yes. Yeah, I actually went through quite a few of different websites. So I downloaded a ton and then figured out some stuff didn't work and some stuff did. Pandas was the one I remember the most. And NumPy and word cloud and yeah, that kind of stuff. Yeah. Unfortunately, I just copied and pasted every single review, which is why I think there could be further development there.
Any other questions?
Python. I think it was a script that somebody wrote online and I kind of adjusted it to make it my own. I think I had, again, it was like, I could find out and tell you later, but there were like 10 on there. So yeah. Yeah.
I'm curious, I'm sure you didn't have time to do this in a like super analytical way, but your own observations having looked at what people said in person, and then after they had people questioning, and then what they said online, taking it up after they had people questioning. Were they similar? Were there differences?
There were some similarities and differences. I think you're talking about your survey data. Yeah, so I think it was more about their hopes on your survey data. So it was like a little bit more catered, but I found a lot of similarities in like the features, the natural features that they were looking at. Yeah. Yeah.
And mute and share screen. And I'm just going to share screen.
Perfect.
Okay. Does that work?
Thank you.
Thank you.
All right, thank you so much.
All right, our next speaker is Laura Gans.
And all right, will someone on Zoom speak up if you cannot hear me? Otherwise, I will assume that you are able to hear. Oh, that made no sense because if you can't hear me, you wouldn't. Okay, great, perfect. All right, thank you so much. Perfect. Well, I have done a lot of research about wilderness and then geotags, which are another form of spatial data shared on social media. And I think this presentation will be more of a summary of ways we can think about how social media interacts with people's experiences outside. So I won't go into a ton of detail into all of my methods to spare you that, but I encourage you to ask me questions after the fact if you want to learn more. And all right, to provide a little bit of background information, a geotag is some sort of spatial identifier that is attached to a social media post that connects it to a specific location. So that could be coordinates or it could be like a text description. And then I am also studying geotagging within wilderness, which is both a social construct or philosophical concept in the United States and a type of federal land protection. And it's often described as untrammeled by man or the epitome of naturalness. And many have argued that geotags are ruining nature because they cause more people to visit outdoor spaces, which leads to more impacts like crowding and damaged vegetation. However, there's been a lot of pushback on this idea by others who claim that social media is great because it creates more equitable access to the outdoors. However, there's not a lot of research exploring this issue, and so my research seeks to try and understand if geotagging contributes to individuals' travel decisions and how, and then to also understand if visitors in these areas perceive the wilderness as being ruined. And then finally, I asked some so what questions, like what does this mean about creating equitable access to the outdoors? So my study area, the same as Eileen, is in the Alpine Lakes Wilderness in central Washington. And to acquire my data, I extracted data from both Instagram and Flickr. So I found a bunch of posts of photos posted publicly on these sites, and I extracted their data from Instagram that looked like scraping text geotags shared with the hashtag Alpine Lakes Wilderness. That's what those looked like when I then went and mapped them. And then for Flickr, that data looked like geographic coordinates that were stored in the metadata associated with the photos. And so I extracted those and then mapped them as well. And then using a geographic information system software, I conducted a hotspot analysis. So that was trying to determine which areas are have the most dense population of geotags given these input points. And I found that there are hotspots throughout the Alpine Lakes Wilderness, but especially near Snoqualmie Pass and then in the Ingalls and Enchantments area. And so using that hotspot map, I identified 4 research sites. They're marked in these red stars here to conduct in-person visitor questionnaires to learn about visitors' actual experiences in these sites. And because they say photos are worth 1,000 words, here's just some examples of geotagged posts from that area. So lots of mountains, peaks, lakes. And so in those visitor questionnaires, I was primarily interested in learning about where visitors got their information to make their travel decisions, and then also to learn more about their experiences. My methods were I conducted intercept sampling in August and September of 2021. Over 10 days, I sampled from around 1 to 5 p.m. and I collected a total of 508 surveys from visitors who entered the wilderness. And the first thing I used those surveys to determine was, do visitors to geotag hotspots in Alpine Lakes Wilderness use social media geotags when making their travel decisions? And I found that most visitors said they did not use social media when making their decisions. But for those who did, that would be this 20% in the green. Social media both motivated, like provided inspiration for their travel, and then it also provided the information they needed to know how to get there. And visitors were primarily using Facebook and Instagram. I then asked follow-up questions to try and understand if visitors use geotags specifically. And very few visitors said they use geotags, although there's potentially error because visitors may not have known what geotags are. Next, I was interested in whether visitors perceive the wilderness as being ruined. And so I looked at this in two ways. First, I looked at, do they notice common recreational impacts like crowding, litter, trail erosion, and trampled vegetation? And I found that some did, but of those who did, most of them were not super impacted by those impacts, with the exception of crowding. Kind of this red percent here shows, this red and darker orange shows that about half of people were either moderately or had experienced a large negative impact from crowding. But overall, visitors' perceptions of crowding varied from some people thinking there were too many people in these spots for wilderness, and then others said, well, it was crowded, but that was okay. We still had a good experience. And then I also asked visitors if their experiences were met and why, and the majority of visitors had their experiences met, and they talked about good hikes, beautiful views, they had a nice time with friends and families. Lots of positive words were used. So kind of synthesizing this together, looking at this research in the context of the geotagging debate, I argue that geotagging is not the primary contributing factor to visitors' decisions. Actually, probably word of mouth and sites like Washington Trails Association and All Trails contribute more. And then within wilderness geotag hotspots, few visitors are strongly negatively affected by recreational impacts, and visitors' expectations are still largely being met. So I don't think there's strong evidence to suggest that geotagging ruins nature for all visitors in Alpine Lakes Wilderness. But so what? Why does this matter? And something that people have pushed back on this geotagging debate about is that this anti-geotagging movement builds upon and reinforces this problematic narrative about the myth of the pristine wilderness that suggests that what makes wilderness valuable is the absence of people in it. What is interesting about this debate, though, is that the critics' presence is okay in nature, but it's newcomers to the wilderness who are kind of framed as being the problem. And there's a whole bunch of research. Many people have explored this idea of wilderness and how we frame it and how we talk about it. And it's commonly spoken about in the United States, the idea that wilderness should be separate from society and separate from people, and we should only visit it as temporary visitors. However, this narrative is both false and problematic. People are integrated with wilderness in so many ways. We shape how we understand wilderness. People have lived in wilderness environments for thousands of years in the Americas. And then additionally, there are these problems for not integrating our ideas of wilderness with society. Like this idea of a wilderness that needs to be pristine and devoid of people was used to justify the violent displacement of indigenous peoples from a lot of public lands, a lot of land in the United States to create national parks and other protected areas. And then also what we do outside of wilderness affects what happens in wilderness. Climate change travels across boundaries, pollution travels across boundaries. So wilderness and society are more integrated than we talk about them as. And so when we talk about geotagging as being a problem because it causes new people to come to wilderness, it reinforces the problematic idea that wilderness is only valuable so long as it protects opportunities for solitude for the people who already know how to access wilderness. And those people are most often white, wealthy, and grew up with the knowledge and the resources to be able to recreate outside. And so in conclusion, I think we should celebrate more diverse ideas about who wilderness is for, what it means to recreate in wilderness,
And I think social media can be a really powerful tool for doing that. James Edward Mills is a Black writer who has written a lot about outdoor recreation, and he argues that people of color, the disabled, members of the LGBTQ community, and women have always been a part of the world outside. In my opinion, what has changed is the ability of these specific affinity groups to control and share their own narratives through social media. So it's a powerful tool for changing the story of the outdoors. And then I have so many people to thank, most of whom are in this room. My thesis committee, Dr. Jen Lipton, Dr. Sterling Quinn, Dr. Carla Jellum. Eileen helped me so much with my survey data. Dr. Bowen taught me how to use stats, which I didn't talk about in here, but didn't use. And then Professor Lizzie Brown is most of the reason why I can go to school here. Has provided a lot of mentorship as well. And then a huge thank you to the Office of Undergraduate Research and specifically a faculty and provost research grant for funding, and then as well some other funders. Yeah, thank you all so much. Okay. Yeah.
Well, I really appreciate the attention paid to minoritize folks and their lack of access to outdoor spaces. I'm wondering if your survey wants to break down gender and or race.
Yeah. Race was, I should have put some extra slides on here to know the actual data. Almost the majority were white, and then also I think like 7% of people self-identified as Asian. There were a few individuals who identified with other ethnic or racial categories, but not very many. Gender was a pretty even split between male and female identifying, and then largely individuals said that their annual household income was like well above 50,000, and many in the above 100,000 and above 200,000 categories.
Did you see gender differences in responses?
Yeah, I looked at whether there was a relationship between an individual's gender, annual household income, self-identified race or ethnicity, and age, and whether or not they use social media to make their decisions. And I found that the only relationship when using a chi-square test was between race, ethnicity, and social media use. So in terms of social media use, my research does not support that gender had an influence. Yeah.
Any other questions?
Yeah. Ooh. Yeah. Gosh. There's so many, and now I can't think of any. I think appreciation. Like people were so, like the number of times people said, thank you. Oh, actually, I'm going to change my answer. You know what I noticed was that no one was mad at me and no one was mad at anyone. And I expected like, oh, this is a contentious issue. Everything in 2020 is contentious. And I think public lands have the power to unite people, even if they have different political views, come from different cultures. Like people were united about like excitement for these places. And I guess I expected conflict because I did the survey, not in 2020, sorry, in 2021, but people were happy. People were nice to me. People were nice to other people. Yeah. Oh, perfect. What? Yeah. Yeah, the question is, how did you decide which locations you wanted to use to collect data? Was any sense of popular hikes used? Yeah. Are you talking about where I collected the survey data? Okay, perfect. yeah, I did. I gave a very, very brief overview of this. So that was informed by downloading all this. Let me go back to it. Oh, I'm probably not sharing screens with you anymore. Going back to all this social media data that I downloaded from Flickr and Instagram. My reasons for using those sites were that Flickr is frequently used in academic research about outdoor places. And then Instagram, many people accuse Instagram as being the site that is ruining nature. And so I extracted all these geotags, this digital location information attached to those photos, mapped it, and then I used statistical analyses in a geographic information software system to identify the most frequently tagged spots. And those are these kind of like hot spots in blue and pink here. And then from there, I chose trailheads to those sites by thinking about the practicality of conducting research in which trailheads led to the majority of those sites. So yeah, my survey sites were informed by this spatial analysis. All right.
Thank you.
Yeah, thank you.
Our last speaker for this session. Thank you. That's great. Are we gonna have your? Then you want to put it here. Do you know? Did you put it on there?
I emailed, but I don't know if it got up or not.
Let's see.
It's not with
Pease,
me.
Pease source. Do you see it there? Is that you?
No.
Okay. It might be there.
Oh.
It might be in the B and C folder.
In the same, oh, I see.
B and C, yeah.
No, I don't.
Okay, just go ahead.
That's fine.
I'm going to introduce you while you're at, and then I'll give you a 5, 3, and 1 minute.
Thank you.
So our last speaker is Megan Cline. Megan's presentation title is Historic Climate Change, Climate Variability, and Streamflow Trends in Kittitas and King Counties. Share your screen. Thank you.
Yep. Right, is that okay.
Let's, or maybe we can try screen
Oh,
two.
yeah.
Let's do that one. Sounds okay.
Awesome. All right. So my name is Megan Cline. I'm part of the Cultural and Environmental Resource Management graduate program here at Central. And today I'm going to be talking a little bit about my thesis research, which is focusing on historic climate change, climate variability, and hydrologic trends in Kittitas and King counties. So climate change, don't have a ton of time to go into all the ins and outs of climate change here. You're welcome to ask questions afterwards, but basically you just need to know warming trends are projected to continue through the current century, anywhere from 1 degree Celsius to more than 5 degrees Celsius. Surface temperatures are projected to increase globally at least until 2050, and that's assuming emissions stopped today. And every additional 0.5 degrees of increment of warming is projected to cause increases in heat waves, heavy precipitation events. It'll change the global water cycle, more variable precipitation and surface water flows, earlier snow melt, that kind of thing. This just shows global temperature anomalies. That baseline is the 1951 to 1980 normals, so the temperature average. As you can see, since 1980, the global trends have just taken off. We no longer have any years that are below that average, and it's way, way above that average, up to 1 degree Celsius. We see the same trends here in the Pacific Northwest. On average, the temperatures have increased by about 1.5 degrees Fahrenheit overall since around 1900, and we're projected to increase anywhere from 3.3 degrees Fahrenheit to almost 10 degrees Fahrenheit by 2099. So the purpose of my thesis research is to document and assess the past climatic trends so that we can then look forward and see what these trends might look like compared with global and regional trends and have an idea of what to expect. So my research questions are doing things like looking at rates, directions, and amplitudes of climate change in these counties, particularly since 1960, though I do have data that goes back further than that. How these rates of change compare between counties and what the possible reasons for similarities and differences might be. If there's a correlation between these changes and any changes we see in the hydrographs during this period, and then how these rates compare to global and regional trends. This will give us a better picture of how climate change has already affected these counties. I'm sure everyone remembers the heat wave of last summer. That's what this map is showing. It's got temperature anomalies above normal. As you can see, Washington was the hottest of any of the states. We got the brunt of it. And this data will be really useful to stakeholders, municipal water managers, farmers, the Department of Fish and Wildlife, as well as the general public and anyone who might be interested in looking at climate change in our area. There haven't really been local level studies like these done, so we are kind of reinventing the wheel here a little bit. Declining snowpack. This map shows rates of snowpack changes. The orange circles are decreases in snowpack. The blue circles are increases. As you can see, up in Washington, the snowpack's just decreasing. The Cascades are in what they call a transition zone, so areas where precipitation frequently transitions between rain and snow. The precipitation is projected to increase slightly during the winter because particularly as rain, essentially any increase in temperature means that there's going to be more rain falling than snow. That's going to impact our snowpack and overall our hydrology and our seasonality in our water cycle. So Kittitas and King County, again, this is my study area. Even though these counties are adjacent, they're very different. Obviously, King County is heavily urbanized. Kittitas County is mostly rural. You've got the windward versus the leeward side of the Cascades. So Ellensburg is in the rain shadow, which you can see on the climate graph for Ellensburg. Really low precipitation, much more seasonality in temperatures. We get much lower lows and higher highs versus on the other side, this climate graph is for SeaTac, which is one of my climate sites. Obviously, again, they have much heavier precipitation, slightly more averaged out temperatures. This is just a quick overview of the topography. The King and Kittitas counties are here outlined by this kind of parallelogram. King County has a lot more lower lying areas. Kittitas County is a lot more elevated. This is going to impact the climate a little bit as well in these two counties. So my methods, not going to go a lot into my methods, don't have a lot of time, but I'm going to talk about these first two a little bit here in the bold. Gathering the temperature data for these counties from different climate data sites, particularly the WRCC and PRISM, which is out of Oregon State, and then graphing these historical temperature and precipitation data. How do we visualize this? So my climate stations, just real quick, these are my 5 climate stations that I'm focusing on. We've got 2 in King County, 2 in Kittitas County, and 1 sort of in the middle at Stampede Pass. So one way we can visualize data is these climate graphs. These are climate graphs showing the Jellum normals from 1961 to 1990 and 1991 to 2020. Climate normals are just kind of an average of the climate in those years. And already we can see some differences. Here you've got, for the 1961 normals, you've got this kind of nice little precipitation U shape. The precipitation gets much more variable for the normals in the next, from the normals from 91 to 2020. So that is one thing that just can jump out at us right away with these kind of graphs, is seeing these differences and just being able to look at them. Another way we can visualize data is tables. Tables are great for getting a lot of information into a small space. So this first table here is again looking at Cle temperature normals. These are the average max temperatures. The first one has 1961 to 1990, the normals for that. The second line here is the 91 to 2020. And then the final line is the difference between the two, whether positive or negative. So again, some things can jump out at us right away. You can see the annual average temperature in Cle has not changed. It's the same, or the average max temperatures. But if you look at July and August, they've increased by almost 1.5 degrees. So the summers are getting much warmer. I don't have it boxed out, but also if you look at October, it's an average of 2 degrees cooler. So again, we're seeing these huge influxes in seasonality, and this lets us visualize those really quickly. The next comparison chart is the differences in max temperature normals. And again, I'm basically pulling out this last line in the Cle one and doing it for every climate site I have and comparing them all across. So again, we can see some trends jump out at us. Stampede Pass almost every month is 2 degrees warmer than normal. That's going to have a huge impact on our snowpack. As I was talking about, the climate is in that transition zone, and it so those, even that 2 degrees impact increase is going to have a huge impact on the snow melt and on the amount of snow falling. The last way we can kind of visualize data, or another way anyways, is these time series graphs. This is the PRISM data for Ellensburg. PRISM is daily climate data from 1981 to 2020. So with this, we can see some huge outliers. We have these much colder days that kind of drop off after about 20 years ago. We don't get as many degrees or as many days below zero. This is also can show us the precipitation data. And again, we can see kind of these huge outliers, and that lets us kind of visualize the data and know what to kind of go look in more depth at. So continued research, I still need to get the hydrograph data so that I can look at Streamflow, and then again, take that data visualization, compare it to global and regional trends. And when I'm done, I hope to have county level climate change data to disseminate to stakeholders. Thank you very much for listening. Thank you very much to my mentors. And are there any questions? Yeah.
I'm curious if there, or if you know, or if you think you will find kind of a tipping point in terms of if we progress on current temperature trends. I mean, when we like stop having very much snow in the Cascades and that switches to rain, and what the implications of that will be.
Yeah, I'm not sure. Because I haven't looked at the snowfall or the hydrologic data yet. I've pretty much just, so far I've just got the temperature and precipitation data, and I'm in the middle of doing all that visually. I'm going to have literally hundreds of charts, so that's going to be fun. That's my whole summer. Yeah, so once I have the, once I have the snow, once I've looked a little more at the snow data and the hydrologic data, we'll be able to see if there's a correlation, and if we can tell when, like if there's a clear, like suddenly there's less snowpack after this point. If there's a correlation, we should hopefully be able to see it, but I haven't looked at the snow data enough yet to know if that's there. Yeah.
I was really struck by the last graph you showed that indicated that negative outliers for Ellensburg data
Mhm.
become less common over the last 30 or 40 years.
Yeah. Yeah, it was, yeah, that's, so that whole, the time series was daily data for the last 40 years. So yeah, like after about 20 years ago, we get a lot less days under zero.
So I'm wondering how much that contributes to the apparent warming trend instead of like the average temperature actually increasing. You know, how much actually increasing. I wonder how much it reduces frequency of severe negative outliers.
Yeah, that's definitely something we're going to look at too, and see like if there's less frequent outliers, does that contribute? It's the same with like the precipitation as well, looking at if those have become more or less common. I didn't have a chance to talk about it, but we can also run outliers through something called reanalysis data, which essentially just reconstructs the atmospheric conditions for that that time period, so we can see what was affecting that. So we can look at that too with those outliers and kind of see how that's contributing as well.
Thank you.